In this lesson, first I'm going to show you how you can solve a three-dimensional system of equations. And then I'm going to show you how you can use that to find a quadratic function that passes through three given points. Now here you see I have an example of a three-dimensional system of equations. When I say three-dimensional, I mean there's three variables. There's x, there's y, and there's z, and there's three equations. And so we have three unknowns and three equations, and that would be a three-dimensional system of equations. And our job is to find out what values of x, y, and z would make all three equations true. Now our strategy for solving a three-dimensional system of equations is to reduce it down to a two-dimensional system of equations, which we've already learned to solve earlier in this class. And here's a strategy for doing that. We'll group two of the equations together. I'll take the first two, and we'll eliminate one of the variables. We can either eliminate x, y, or z. Now I'm going to choose x because the x's are already opposites here, negative x and positive x. And that's really going to make it easy to eliminate the x because we'll just add the two equations together, and that'll make the x's cancel. So we're going to eliminate x from those first two equations. And then we'll group two other equations together. Now we can either use the first and the third or the second and the third, as long as it's a different combination than we started with. And we have to eliminate that same variable. So I'll use the second and the third, and we'll eliminate x from those as well. So our strategy is going to be to group the top two equations together and eliminate the variable x, and then group the bottom two together and eliminate that same variable x. And that'll give us two new equations that have y and z. So it'll be a two-dimensional system, and then we'll solve it as we have in the past from there. Alright, so let's go ahead and do this. So I'll start with the top two. Okay, so we're working on these two here, and we're going to eliminate x. And since we already have opposites, as I mentioned, all we need to do is add those two equations together. So we have negative x plus y plus z equals 6. And then we have x minus 2y plus 3z equals 5. And since the x's are already opposites, we can just add these together. The x's cancel. We get negative y plus 4z equals 11. Okay, now we'll do the same thing with the bottom two equations. Now we also want to eliminate x here, but here the x's aren't opposites. But if we multiply the top equation by 2 first, then they will be. So we'll multiply this middle equation by 2. So that would be 2x minus 4y plus 6z equals 10. And then we'll add that to the third equation. And when we add those, the x's will cancel out, and we'll get negative 3y plus 4z equals 9. Now we want to take this equation that we just came up with and combine it with this other equation that we came up with a minute ago. So I'll write this answer over here underneath our other answer. So we've got negative 3y plus 4z equals 9. Now these two equations together really is a two-dimensional system. We have two equations with two unknowns. And we want to try to get opposites. And the easiest variable to get opposites would be the z's, because you already have a 4z and another 4z. Now right now they're both positive. We want one of them to be negative. So let's multiply the top equation by negative 1. That would be y minus 4z equals negative 11. And then we'll add that to the other equation. And that'll make the z's cancel out, and we'll get negative 2y equals negative 2. And now we can just divide both sides by negative 2, and we'll get y equals 1. Now at this point we want to kind of back substitute to get the other variables. So if we take this answer, y equals 1, and we plug it into one of these two equations, we can then find z. So I'll just use the top equation here, and that would give us negative 1 plus 4z equals 11. So 4z equals 12 if you add 1 to both sides, and then divide by 4, so z equals 3. Okay, now that we know both y and z, we can plug both those answers into one of these three original equations to find the x. So I'll just use the top equation. So we have negative x plus y. Now remember, y equals 1, so I'll plug that in, plus z, and z equals 3, equals 6. So negative x plus 4 equals 6. If we subtract 4 from both sides, we get negative x equals 2. And then divide by negative 1, so x equals negative 2. So those would be our three solutions for x, y, and z. We have x equals negative 2, y equals 1, and z equals 3. And we've solved this system. Now you can always check your answers by taking these three values, negative 2 for x, 1 for y, and 3 for z, and substituting them into each of these three equations, and they should all come out to be true. And if they do come out to be true, then you're sure you have the right answer. And if they don't, then you know you've made a mistake somewhere and you can go back and try to find it. Now we want to apply the procedure I just went over to be able to find a quadratic function that passes through three given ordered pairs. So in this example, I've given three different ordered pairs. We have 2, 3, and 3, negative 2, and 4, negative 11. And we're trying to find a quadratic function that passes through those three given points. Now remember, a quadratic function is going to have the equation y equals ax squared plus bx plus c. And it's going to be the shape of a parabola. So we're trying to find a parabola that passes through three given ordered pairs. Now the first step in doing this is to take each ordered pair one at a time and substitute the x-coordinate in for the x and the y-coordinate in for the y in our equation. So let's start with the ordered pair 2, 3. So we're going to substitute a 2 in for x and a 3 in for y. So that gives us 3 equals a times 2 squared plus b times 2 plus c. And we want to simplify that, so I'm going to write that over here. So that really gives us 3 equals 2 squared is 4, so we have a times 4, so 4a. And then b times 2, we'll write that as 2b plus c. Okay, now let's do the same thing with the second order pair. This time we're going to plug a 3 in for x and a negative 2 in for y. So we have negative 2 equals a times 3 squared plus b times 3 plus c. And that's going to simplify into negative 2 equals 3 squared is 9, so we have 9a plus 3b plus c. And now we'll do the same thing for the third ordered pair. So we'll plug a 4 in for x and a negative 11 in for y. So negative 11 equals a times 4 squared plus b times 4 plus c. That gives us negative 11 equals 4 squared is 16, so 16a plus 4b plus c. Now, this result that we end up with is a three-dimensional system of equations. there are three variables. The variables are a, b, and c, and that's what we're trying to find. And we have three equations. So we're going to solve this system using the method I just showed you a minute ago. Okay, so here's the system that we want to solve. Now notice that they all end with plus c in all three equations. And that's always going to happen here because that's just the way it works out when you do this kind of a problem. That makes it easy to eliminate the c because all you have to do is multiply one equation by -1 and they're going to be opposites. So our strategy is going to be, we'll group the first two together and we'll eliminate c. And then we'll group, we could either do the first and the third or the second and the third. It doesn't really matter. I'll do the second and the third. And we'll eliminate c there. And that will reduce that down to a two-dimensional system. Then we'll go from there. Okay, so that's our strategy. So I'm first going to do this top one. So I'll do the top two equations, the first and the second equation. And I'll multiply one of them by -1. I'll multiply the first equation by -1. So -4a minus 2b minus c equals -3. And combine that with the second equation. And when I add those together, the c's are going to cancel because one's negative and one's positive. And I'll have 5a plus b equals -5. Okay, now we'll do the second part. We'll do the second equation with the third equation. And again, we're going to have to multiply one of those by -1 and add it to the other equation. So I'll do the second equation times -1. So that's -9a minus 3b minus c equals +2. And combine that with the third equation. And again, the c's are opposites, so they're going to cancel out when you add these. And so you'll have 7a plus b equals -9. Now we want to take these two equations that we just came up with, this one here and this one here, and combine them together. So I'm going to write this one underneath this other one here. So let's put the 7a plus b equals -9 under that one. And now I want to try to eliminate either the a or the b. Now the b's would be easier because you have a positive b and a negative b. And if we multiply one of them by -1, we can add it to the other one and eliminate the b. So our next strategy is going to be to eliminate b from those two equations. So I'll multiply the top one by -1, so -5a minus b equals +5, and combine that with the bottom equation. And when we add that, we get 2a, the b's cancel, equals -4. And when you divide both sides by 2, you would get a equals -2. Now we can kind of back substitute to get the other variables. So if we take this answer, -2, and plug it into either one of these two equations, we can get b. So I'll plug it into this top equation right here, 5a plus b equals -5. So we'd have 5 times -2 plus b equals -5. So -10 plus b equals -5. And if you add 10 to both sides, you get b equals 5. Now if you take both of those answers for a and b and substitute them into one of these original three equations, you can find the c. So I'll just plug everything into the very top equation here. 4a plus 2b plus c equals 3. So we get 4a, so 4 times -2, plus 2b, so 2 times 5, plus c equals 3. So negative 8 plus 10 plus c equals 3. So 2 plus c equals 3. And if you subtract 2 from both sides, c equals 1. Now remember, we were trying to find an equation of the form y equals ax squared plus bx plus c, which would be a parabola, or a quadratic function. And we just found out what the a, b, and the c need to be. So we'll substitute those in. So our answer will be y equals negative 2x squared plus 5x plus 1. This should be the quadratic function that passes through the initial 3 ordered pairs that we were given. Now we can check this on a graphing calculator. Now remember, the original order pairs that we were given were 2, 3, 3, negative 2, and 4, negative 11. So on our calculator, we could enter those into L1 and L2. If we push stat and then edit, we can put the x's in L1 and the y's in L2. So the x's are 2, 3, and 4. And the y values would be 3, negative 2, and negative 11. And if we do a scatter plot of just those 3 ordered pairs, it'll plot them. So let me do second stat plot to make sure my stat plot is turned on. And it is, it's turned on. And then to get the scatter plot, we just do zoom and then 9. And you can see those 3 points show up. Now if I press y equals now, and I enter in the function that I found, which is negative 2x squared plus 5x plus 1, and then I hit graph, it should graph that parabola along with the 3 points, and hopefully it passes through the 3 points, because that's what it's supposed to do. And you can see it does do that. So that checks that it's the correct answer. So we found a quadratic function, or a parabola, that passes through those 3 given order pairs. Let's try one more example of this. Now again, we're asked to find a quadratic function that passes through 3 given order pairs, 0, 5, 213, and 326. This problem is slightly different than the one we just did, because this first order pair right here happens to be the y-intercept. And the reason I know it's the y-intercept is because the x-coordinate is 0. And that actually makes the problem a lot easier. When one of the 3 given points has an x-coordinate of 0, meaning it's the y-intercept, the system is a lot easier to solve, as you'll see in just a minute. So we start out the same way, though, by, again, we're looking for a quadratic function. So it's going to be of the form y equals ax squared plus bx plus c. And we're going to go through each order pair one at a time and substitute the x coordinate in for x and the y coordinate in for y. And that'll create a 3-dimensional system. So let's start with this first order pair, 0, 5. And we're going to plug the 5 in for y and the 0 in for x. So 5 equals a times 0 squared plus b times 0 plus c. Now when we simplify that one, we just get 5 equals c. Because when you multiply something by 0, the answer is just 0. So we actually get c right away. And that's why this ends up being a little easier. Okay, now we'll go on to the next order pair. We'll plug a 2 in for x and a 13 in for y. So 13 equals a times 2 squared plus b times 2 plus c. That one simplifies into 13 equals 4a plus 2b plus c. And then we'll go to our third order pair. We'll plug a 3 in for x and a 26 in for y. So 26 equals a times 3 squared plus b times 3 plus c. And then we'll simplify that down. So it's 26 equals 3 squared is 9. So 9a plus 3b plus c. Now in this case, since we know c is 5 from this first equation, we can plug that answer in for c in these other two equations. And when we do that, that immediately reduces it to a two-dimensional system because it eliminates the variable c from the equations. So that would give us, for the top middle equation, okay, right here, we would have 4a plus 2b plus 5 equals 13. So I'm going to write that down here. So 4a plus 2b plus 5 equals 13. And for the other equation, we'll have 9a plus 3b plus 5 equals 26. Okay, so let's work at solving this system. Now the first thing we do is we subtract 5 from both sides of each of those two equations. So in the top equation we'd have 4a plus 2b, and if you subtract 5 from both sides you just get 8. And for the second one we have 9a plus 3b equals 21. Now we have to try to eliminate either a or b. I'm going to choose to eliminate b. And to do that, I'm going to multiply the top equation by -3 and the bottom equation by 2. So, let's see here. So if we multiply the top equation by -3, so times -3, and the bottom equation times 2, let's see what we get. So we'll have -12a minus 6b equals -24, and then in the bottom we'll have 18a plus 6b equals 42. And now we have the opposites, -6b and +6b, which is what I wanted. And so now I'll go ahead and add these together, which gives me 6a equals 18. And then if I divide by 6 on both sides, a equals 3. Now remember, we've already found c. c was equal to 5, which we had found at the beginning. So all we have left to find is b. So now I can use one of these equations right here to find b, because if I take my answer for a, which is 3, and plug it in, it'll allow me to find b. So I'll use this top equation right here. 4a plus 2b equals 8. So I'm going to substitute in the answer for a. So 4 times 3 plus 2b equals 8. So 12 plus 2b equals 8. Subtract 12 from both sides. So 2b equals -4. And then b would be equal to -2. So remember, we were looking for an equation of the form y equals ax squared plus bx plus c. So we'll substitute the a and the b and the c into that. So we'd have 3x squared plus, or actually minus 2x plus 5. And that would be our quadratic function, which should pass through the three given ordered pairs. Now I checked this on my graphing calculator using the same procedure I showed you in the last example. I first went to stat and then edit and entered in the three ordered pairs, and then I pressed y equals and entered in our answer here for our quadratic function. And then I just did zoom 9 because that would give you a good picture of that. And you can see that we get a parabola that does pass through those three given order pairs, so it checks out fine. So now you know a procedure that you can use to find a parabola or a quadratic function that passes through three given ordered pairs.